Okay, the fourth rule. For this one, we need to draw a quadrilateral within the circle. So it's actually called a cyclic quadrilateral. Each point has to touch the edges of the circle so that the quadrilateral can't just be in the middle, it has to be touching the edges. Now, opposite angles inside the cyclic quadrilateral add up to 180 degrees. So the two blue ones add up to 180 degrees and the two yellow angles add up to 180 degrees. Okay, this first example is pretty straightforward. So because we know that we've got a cyclic quadrilateral, opposite angles add up to 180. So to find A, 180 subtract 69, you get 111 degrees. The same thing for B, 180 subtract 128, and we get 52 degrees. With this one, we had to use angle rules. So angles on a straight line add up to 180. So we know that this blue angle here is 80 degrees. We then use that to find C. So 180 subtract 80 gives us 100. And you will notice that those two angles are exactly the same. So you should be able to work out what D is straight away without doing anything. But if you wanted to work it out, 180 subtract 119 gives you 61. Then use angles in a straight line to find angle D, but you'll notice it's just the same. Okay, a few different parts to this question. First one, we are looking at the triangle on the right, which is an isosceles triangle. So we know that the blue angle there is 35 degrees. So then we can use angle rules for triangles. So 35 add 35 gives us 70. Subtract that from 180 and you get that the red angle is 110 degrees. Now we're looking at the cyclic quadrilateral, so what I've highlighted here in yellow. If we know that red angle is 110, the opposite angle to that is going to be 70 degrees. Now if we look at the isosceles triangle on the left-hand side, because we know that the bottom left angle is 70, the bottom right angle is also 70, which means the top angle we can find by using angles in a triangle. So 70 add 70 is 140, subtract that from 180, you get 40 degrees. So that top angle of that isosceles triangle is 40 degrees. Then to be able to find E, we're going to use angles on a straight line, which I've highlighted in green, add up to 180. So 40 plus 35 is 75. 180 subtract 75 gives you 105 degrees. Okay, so what I'd like you to do, there are green questions, yellow questions and red questions. Work your way through them. And then the answers are right at the end of the video. I just want you to self-mark them. If you have any problems at all or you can't see how the answer can possibly be that one, if you just take a picture of your workings and send that to me, or just give me a message and I'll try and get back to you as soon as I can. Okay, for rule 5, you're going to draw a tangent, so a line that just touches the edge of the circle, and then draw a radius that meets it. And the rule is basically that wherever a radius meets a tangent, it will be 90 degrees on both sides. For the next rule, if you draw a point outside the circle and then draw two tangents from that point, both of those lines will be exactly the same length. Okay, first example, because you know that these two tangents are the same length, it means this is an isosceles triangle. You can use angles on a straight line, which I've highlighted yellow, to find the red angle. So 180 subtract 92 degrees gives us 88 degrees. So both of these would be 88. Then angles in a triangle, 88 plus 88, subtract that, or 88 times 2, subtract that from 180, and you will get 4 degrees. Now, looking at this, it doesn't look like 4 degrees, but remember that most or all of these will not be drawn to scale. Okay, this one. This is also an isosceles triangle because we've got two tangents touching a circle. So these two blue angles will be the same. So 180 subtract 82 gives you 98 degrees. Divide that by 2 to find out what each of them are, and you get 49 degrees. Okay, you will see the line that touches the tangent also creates a 90-degree angle. Now, if we subtract the 49, we'll find what the little bit inside the triangle is. So we've got that yellow angle there is 41 degrees. Also from a previous rule, we've got a triangle inside a semicircle, so that red angle there we know is 90. And then you can use your angles in a triangle, so 90 plus 41 is 131, 180 subtract 131 is going to give you the angle C, which is 49 degrees. Now you will notice that this angle here, this 49, this blue one, is the same as C, and that's the next rule that we will get to. So you could have done this by sight when you know the next rule. But in the exam, if you use different rules, but they still can be applied, you still get the marks. Okay, final rule. This one has a name, so it's called alternate segment theorem. And basically, if we draw a tangent to a triangle inside a circle, the opposite angles will be the same. So you can see there the two blue angles will be exactly the same, and the two green angles will be exactly the same. Okay, first example, you didn't really have to do anything, any working out. You just had to spot that A was the same as the bottom left, so it would be 35 degrees. And B would be the same as the top left, which was 77 degrees. Next, we've got a triangle inside a semicircle. So we know that this angle here is 90 degrees. Using alternate segment theorem, we know then that C is exactly the same angle, so also 90 degrees. Then you can use angles on a straight line, so 90 plus 34 gives you 124 degrees, and then subtract that from 180 degrees. And you get 56 degrees. Okay, next we've got an isosceles triangle again, so we can find the two red angles by using angles in a triangle. So 180 subtract 74 and then divide it by 2. So each of those angles are 53 degrees. Then alternate segment theorem, so E will just be 53 degrees.